Have you ever wondered if the universe goes on forever, stretching out endlessly in every direction, or if there's a boundary somewhere out there, a cosmic edge we'll never reach, or maybe you've thought about the tiniest things, if there's something smaller than anything we can imagine, or if you could keep dividing things forever, never reaching the smallest piece. That's infinity, a concept that's both obvious and impossible. It's everywhere in our imagination, but when we try to pin it down, it slips through our fingers. Infinity breaks the rules of counting. It's not just a really big number, it's something beyond numbers, something that never ends, no matter how high you count. Add or subtract from it and it stays the same. You can't make it bigger or smaller because it's already beyond all limits. That's why some say it's just a paradox, not something real. It seems to break the rules of logic and common sense, making us question if it's just a trick of language or a flaw in our thinking. Yet, without infinity, much of modern science and math, like calculus, which helps us understand motion, change, and even the orbits of planets, wouldn't work. Infinity is woven into the very fabric of our scientific understanding. So, is infinity a real part of the universe, or just a trick of the mind? The answer isn't simple. Some believe infinity is out there, waiting to be discovered, while others think it's just a useful idea we invented. Exploring infinity means questioning our place in the cosmos and the limits of our imagination. It challenges us to think bigger, to wonder about things we can't see or touch. We're finite beings, but we keep reaching for the infinite. Our curiosity drives us to explore the unknown, to ask questions that may never have final answers. The story of infinity is about humanity's quest to grasp the biggest idea of all. It's a journey that has inspired philosophers, mathematicians, and dreamers for centuries. Let's dive in and see if we can unravel this mystery together, and maybe, along the way, discover something new about ourselves and the universe we call home. In the heart of ancient Greece, a philosopher named Zeno crafted a series of paradoxes that would puzzle thinkers for centuries. These weren't just clever riddles, they were deep challenges to the way we understand the world around us, especially the mysterious concept of infinity. Zeno's paradoxes were designed to make us question what we think we know about space, time, and motion. He wanted to show that our everyday logic might not be enough to grasp the true nature of reality. His most famous paradox goes like this: to cross a room, you must first go halfway, but before you can get there, you have to go half of that distance, and then half of what's left, and so on, dividing the distance into smaller and smaller pieces, forever. This means that, in theory, you'd have to complete an infinite number of steps to reach the other side. It's a mind-bending idea. If there are always more steps to take, how can you ever finish the journey? Zeno's puzzle forces us to confront a strange question. If you must complete an infinite number of tasks, is it even possible to finish it all? It seems impossible, yet we cross rooms every day without a second thought. This paradox made ancient philosophers wonder whether space and time are truly continuous and infinitely divisible, or if they're made up of tiny, indivisible chunks, like the grains of sand on a beach. If everything is made of tiny pieces, maybe there's a smallest possible step. But if not, then the puzzle of endless division remains. The Greeks, brilliant as they were, couldn't solve this riddle. Instead, they decided to treat infinity as something you could get closer and closer to, but never actually reach, a potential, not a reality. For them, infinity was always just out of reach, a concept that existed in theory but not in the real world. It was a potential, not an actual thing you could hold or measure. Zeno's paradoxes reveal how infinity can break our intuition and challenge the very foundations of logic and mathematics. We're used to counting steps, measuring time, and thinking in terms of beginnings and endings. But infinity suggests a journey with endless steps that somehow still manages to finish. Imagine climbing a staircase with an infinite number of steps, yet somehow reaching the top. It's a concept that feels impossible, yet it's at the heart of Zeno's puzzle. For more than 2,000 years, mathematicians and philosophers wrestled with this paradox. It wasn't until the development of calculus and new ideas about infinity that a solution finally emerged. The breakthrough was realizing that an infinite process, like adding up endlessly smaller steps, can actually have a finite result. This idea changed mathematics forever. By accepting that infinity can be tamed and used as a tool, we transformed our understanding of motion, space, and the infinite itself. Today, infinity is not just a puzzle, it's a powerful concept that helps us explore the universe, solve problems, and push the boundaries of what's possible. For centuries, infinity was taboo in math, until Georg Cantor changed everything in the late 1800s. Cantor asked, could there be different sizes of infinity? He showed that the set of whole numbers is one kind of infinity, countable, called Aleph null. But the set of real numbers, including all decimals and irrationals, is a bigger, uncountable infinity. You can't list all real numbers without missing some. Cantor's ideas were so radical, many mathematicians rejected them. But he was right. There are many infinities, some larger than others. Cantor turned infinity from a paradox into a rich field of study. His work changed mathematics forever. Infinity was no longer just endless, it had structure and hierarchy. To unravel the mind-bending rules of infinity, mathematician David Hilbert imagined a hotel like no other, a hotel with an infinite number of rooms, each one already occupied. At first glance, it seems impossible to fit anyone else in. After all, if every room is full, where could a new guest possibly go? But in Hilbert's hotel, the ordinary rules don't apply. When a new guest arrives, the manager simply asks every current guest to move one room up. The person in room 1 moves to room 2, room 2 to room 3, and so on, down the endless corridor. Suddenly, room 1 is free, and the new guest has a place to stay. No one is left without a room. Now, imagine an infinite bus pulls up, packed with an endless line of new guests. In a normal hotel, this would be a disaster. But here, the manager has a clever solution. Every guest already in the hotel moves to the room with double their current number. Room 1 to room 2, room 2 to room 4, room 3 to room 6, and so on. This leaves all the odd-numbered rooms open for the newcomers, and everyone fits perfectly. Hilbert's hotel reveals just how strange and counterintuitive infinity can be. Our everyday ideas about space and capacity simply don't work here. Adding infinity to infinity doesn't make the hotel any bigger. Instead, it's like shuffling an endless deck of cards. There's always a way to rearrange things so everyone has a place. This playful thought experiment brings Georg Cantor's revolutionary ideas about infinite sets to life, making the abstract concrete and the impossible imaginable. Infinity isn't just a vague concept, it follows its own consistent logical rules. Even if those rules seem bizarre or even paradoxical at first. The hotel isn't magic or a trick of the imagination. It's simply infinite, and that changes everything about how we think of numbers and space. Hilbert's hotel helps us see that infinity isn't chaos or confusion. It's a new kind of order, one that challenges and expands our understanding. In this hotel, logic reigns supreme. It's a playground for mathematical ideas, not a contradiction or paradox. With the right rules, even infinity can be managed, organized, and understood. One guest, one room, one step at a time. That's the beauty and the delightful strangeness of infinite sets. They invite us to think bigger and to see the world in a whole new way. For over a century, Cantor's infinities shaped math. But in 2025, mathematicians discovered something stranger: chaotic infinities. These aren't neat, countable sets. They're wild, unpredictable, and can't be described by simple rules. They emerged from studying infinite networks and artificial intelligence. In these systems, adding a single element can cause the whole structure to change unpredictably. Unlike Hilbert's hotel, there's no way to manage or organize these infinities. Their key property: computational irreducibility. You can't shortcut their construction, you have to build them step by step. These discoveries challenge the idea that math is always neat and eternal. Some infinities are messy, complex, and unknowable until you see them unfold. The mystery of infinity is only getting deeper and weirder. Infinity isn't just big, it can be chaotic. Not everyone trusts infinity. Some mathematicians, called funetists, argue it's a mistake. They say only numbers you can actually count or construct exist. Infinity, they argue, leads to paradoxes, like Hilbert's hotel, where a part can be as big as the whole. In physics, infinity signal breakdowns in our theories, like black hole singularities. Ultrafinitists go further, doubting even huge numbers that can't be written down. For them, math should describe what's tangible and finite. Infinity is a beautiful illusion, a shortcut that sometimes works, but often leads to absurdity. They urge us to build science on what's knowable, not on endless dreams. Is infinity just an idea, or does it show up in nature? Fractals, like snowflakes, repeat their patterns endlessly in math, though real snowflakes are finite. The coastline paradox: the more closely you measure, the longer it gets, approaching infinity with smaller rulers. Infinity helps us describe complexity in nature. The universe itself might be infinite, or it might curve back on itself and be finite, but unbounded. We don't know if space goes on forever. If it does, there could be infinite galaxies, and even infinite versions of you. We're limited by what we can measure, but infinity lets us model the world's complexity. Whether or not it's real, infinity shapes our understanding of reality. It's a tool for exploring the unknown. Infinity is everywhere, in math, in nature, and in our imagination. It's how we reach beyond our limits. Computers are finite, but they constantly deal with the idea of infinity. Alan Turing proved there's no way to know if a program will halt or run forever. An infinite loop. Programmers design systems to handle endless data streams, like your social media feed. Infinity is a practical tool. It helps test limits and design robust software. Infinite loops are bugs to avoid, but the concept of infinity is always lurking. In AI, the search space can be so vast it's effectively infinite. Computers can't reach infinity, but they're always chasing it. Infinity is both a challenge and a benchmark in technology. We've chased infinity from ancient paradoxes to modern math and technology. Some see it as a real part of the universe, others call it a useful fiction. Infinity inspires breakthroughs and challenges our assumptions. Maybe it's not about whether infinity is real like a rock, but whether it's useful, beautiful, and pushes us to think bigger. Infinity bridges the known and the unknowable. It's a mystery that may never be solved. So, what do you think? Is infinity real, or the grandest story we've ever told?